chapter 32. Um, it's titled Simplifying a Sum or Difference of Polynomials. Okay, and basically what we're doing in this chapter is we're combining like terms. So far, we've only dealt with variables that have a exponent of 1 or a non-variable number, a constant. Okay, and so we've combined numbers with like variables. Well, in this chapter you'll see that you can have the same variable, but then if the exponent's different, then you cannot combine those terms. So we're not just looking at the variables anymore. So we start out with a definition. A polynomial: it's the sum of one or more algebraic terms with only whole number exponents of the variables. Okay, so for instance, our first question that we're posed with is this. We have two sets of parentheses and we have the sum of the two. Okay, in this first set of parentheses we have a polynomial, and there are 1, 2, 3 terms that are being added. So a constant can be considered its own term. And then in the second set of parentheses we have 1, 2, 3 more terms. Okay, so it wants us to simplify this sum. This is polynomial 1 and polynomial 2. Okay, and a polynomial is simply when we have variables and we have x squared, x, there's no variable in this term, and then we have another x squared and x term. Notice that these exponents are whole numbers. Okay, the exponent of the x is 1, and then we could take the 2 off to the side and call this a 2 times the x to the 0, because anything raised to the 0 power is just a 1, and so we still have a 2. We could place the variable beside it, x, but we would have to give it the power of 0. However, 0 is still a whole number. So we have a polynomial plus a polynomial. Okay, so how does this play out? Oh. So down below, they've worked it out, and what they're showing us here in this first line is that in front of each set of parentheses we have an invisible 1. Okay, so there is a 1 in front of the parentheses, the first set, and then there is a 1 multiplying the second set. Both of these 1s are multiplying the set of parentheses that they're in front of. And this is just to simply say that we could distribute to get rid of the parentheses, but the 1 isn't going to change any of the terms, the sign nor the coefficient of the term. Okay, so in a nutshell, we can just drop the parentheses. They aren't needed anymore. And now what we do from this line to the next one is we rearrange our terms. Okay, and so the commutative property of addition says that we can rearrange all of these terms as long as we take the sign with the number of the term. So notice that we took negative 7x and we moved it over to the right, and then we took 3x squared and we moved it over to the left, and the 3 took the plus, and then the 7 took the minus in front of it. Okay, so you can move these terms around, but the sign has to go with it. Now, The reason why we moved 3x squared over to the left is so it would be right beside the 4x squared. And then the negative 7x was moved over to set beside the 5x. And then in the end, we have the two constants side by side. And each number or term that was moved kept the original sign that was in front of it. Now, x squared and x squared terms. Okay, when we combine like terms, we just simply compare the variables and the exponents of those variables. If they're the same, then we keep the common variable part. We do nothing with the exponents. And so we keep the x squared, and we simply add the coefficients 4 plus 3, and we get a 7. And the same goes for the rest of the like terms. Okay, these second two here both have an x. Their exponents are 1. They're the same exponents, and that's important. They have to be the same exponents. So they're both x terms. A negative 7 minus a 5 is a negative 12, and we keep the common variable part. And then a negative 1 plus a 2 is a positive 1. And so we've reduced this polynomial from one with 6 terms to one with 3. We've simplified it. And so that's what we're going to do ourselves in example 1. Okay, what you want to do first is you want to check in front and behind the parentheses and make sure there aren't any numbers immediately to the left or the right outside of the parentheses. Okay, and so we can interpret this as a 1 times a 6t squared minus 7t minus 1 plus a 1 times 3t squared minus 5t plus 4. In other words, we can just simply drop these parentheses. There's just a 1 sitting in front of them. So we can write 6t squared minus 7t minus 1 plus 3t squared minus 5t plus 4. So with a plus in front of the parentheses, we keep the signs that are contained within the parentheses. At this point, we have like terms with the 6t squared and the plus 3t squared. Then we have like terms of negative 7t and negative 5t. I'll circle those. And then we have the constants, negative 1 and positive 4. And we're simply going to add these together. We have a 6 plus a 3. We take the signs of the coefficients and we put the common variable part behind them. For the t term, and I've used the t squareds, for the t terms I have a negative 7 minus 5, and I put the common variable part behind them, the t. And then a negative 1 plus a 4 simply gives us a 3. Combining the coefficients, adding the coefficients of the t squared, I get 9. And then negative 7 and a negative 5 would give me a negative 12. So I'll write subtract 12t and then plus 3. And all of the like terms have been combined at this point. And so this would be as far as we go. Okay, same case with the next part, B part. We have two sets of parentheses. This is a polynomial, and this is another polynomial, poly 1, and then add another polynomial to it. Okay. Once again, take note of what's in front of the parentheses. Okay, there's nothing there, and in front of this set we have a plus, and so in front of each one we interpret the problem as there being a plus 1 in front of each. Okay, with that being said, we can just simply remove the parentheses and write u squared plus 2 plus 7u squared minus 5u minus 3. We pick out our like terms, u squared plus 7u squared, and then we have a 2 and a minus 3, and the negative 5u has no other terms that are like it. Okay, so nothing's going to change about the minus 5u, but we can add the 1 and the 7 of the u squared to get an 8u squared. Then we just simply write out the 5u beside that, and in the end we write our constant that comes from 2 minus 3, and we have a negative 1. So this would be our final answer. This polynomial is the simplified version of the sum of these original two. When subtracting polynomials, you have to treat the negative sign differently. What we do is we treat it as if the subtraction symbol were a negative 1 that needed to be distributed throughout that set of parentheses. And so we can easily turn the subtraction of two polynomials, which we're considering this first set, the first polynomial, and this second set of parentheses, the second polynomial. And then in the center we have subtraction. So if this is the case, and the same would apply if we had a negative in front of the first set, we distribute a negative 1 throughout the parentheses. So negative 1 times 7, negative 1 times 6, and negative 1 times 3. What that does is it changes the signs of the terms inside. Now, in this case we kept the parentheses. We could have dropped them at that point, but now you can see that we've changed to an addition problem of two polynomials, and we're back to having a plus 1 in front of each. When that's the case, we simply drop the parentheses and keep the signs that are contained within the parentheses. So this would be a minus 7y squared minus 6y minus 3. And we pick out the like terms, y squared, combine that with a y squared. I'll draw a circle around the y terms, y to the first power, and then our constants, negative 5 and negative 3. So we have a negative 1 minus 7. We combine those coefficients, and we write that number in front of the y squared. Then we take the coefficients of the y terms with their signs. So this would be a 4 minus a 6. We place that number in front of the y, and then we subtract or combine the constants, negative 5 minus 3. So in the end we get a negative 8y squared, a minus 2y, and a minus 8. Alright, so once again we have a polynomial and a second one, and we are subtracting. Okay, we're subtracting the second one from the first one. Alright, the first one, I just simply look to the front of the polynomial in front of the parentheses, and there's no number written, so it's understood to be a plus 1. I drop the parentheses, and then for the second set I'm going to distribute the negative. Each term inside of the parentheses will be multiplied by a negative 1. So a negative times a positive 7 is a minus 7v squared. A negative times a negative 2v is a plus 2v. A negative times a plus 1 is a minus 1. Once you've removed the parentheses, you are free to combine like terms. 3v squared minus 7v squared, there's a constant, there's another one, and then the single variable term, v to the power of 1. There's only one of those. So for v squared, we have coefficients of 3 and negative 7. If we add those together, a 3 plus a negative 7, we get a negative 4. And we simply put that as the coefficient of the v squared term. And then we have our next term, a plus 2v. It stays the same because there were no other v terms to add to it. And then we have a plus 5 and a minus 1, which gives us plus 4. And at this point we'd be finished. Alright, the first set of parentheses in part B has a plus 1 in front of them, so we can simply just drop the parentheses, and then we'll distribute the negative in order to drop the second set of parentheses. A minus minus 1 would be a plus t squared. A minus plus 7 would be a minus 7t, and then a minus plus 3 is minus 3. So this is a negative 1 times a negative 1. A negative 1 times a positive 7, and then a negative 1 times a plus 3. So it simply changes the signs that were inside the parentheses, and then we don't write them. We drop the parentheses. Okay. Up. Plus 6 plus t squared and minus 7. Alright. Here is our t squared term. We can combine that with this other t squared term, and notice I include the sign in front. We have two t terms, negative 2 and negative 7t, and then here are the constants. So 5 plus 1 is 6t squared. A negative 2 and a negative 7 give us a negative 9. And then 6 minus 3 gives us a plus 3. And that's all there is to it. Like terms have to have the same variables, and those variables have to have the same exponents. Okay, well, now we're moving on to adding several polynomials instead of just two. We have polynomial 1, addition, polynomial 2, subtraction, so we're mixing the operations, and then we have a third polynomial, and then we can call this last one polynomial 4. And we're subtracting. Alright, so we're going to have to get rid of 1, 2, 3 sets of parentheses, and we simply look in front and check that there's a plus 1 there. If that's the case, we do nothing but rewrite it without the parentheses. For the second polynomial, the second set of parentheses, we have a plus 1. So this is plus 6x squared minus 2x plus 3. We change nothing about the polynomial. We simply just remove the parentheses. Now for the third polynomial, here's our parentheses. and we have a negative in front, so we have to distribute that to the terms inside. So we'd end up with a plus x squared and a plus 9x, and then the fourth one was simply written without parentheses, so we would just write minus 3. We'll go back and pick out the like terms. I'll put a box around the x squared terms along with the signs in front. I'll circle the x terms, and then I'll scribble underneath the constants. So for x squared, what's the coefficient? What number do I write in front of the x squared? Well, to figure that out, I simply combine the negative 4, the 6, and the 1, which gives us 3. For the x term, I have 2 minus 2, so 2 minus 2 is 0, and so right now I have 0x term, but then I have a 9 on the end, and so that leaves me with a plus 9x. And then for my constants, 8, 3 is 11, I subtract the 3, I'm back to 8, and at that point I'm done. I get 3x squared plus 9x plus 8. Okay. Now, example 4. One thing you need to notice is that we no longer have x variables. We have some y variables mixed in. And so we'll have to be careful about which terms we combine. Now, as far as the parentheses go, we can still drop the parentheses if there is a plus 1 in front. Okay? Or if there's no number written, then it's understood to be a positive 1. So the first set, we just drop the parentheses. The second set has a minus in front, and so we distribute that minus, and it changes the signs of the terms inside. A minus minus 3 is a plus 3, and then we have a minus 5x. So once you drop the parentheses, you can start looking for like terms. Okay, if we compare the first and the second, okay, we have a y squared and an x. These are not like. The first two terms are not like. This one has a y squared and this one has no y's, so these two cannot be combined. However, this x term can be combined with this x term on the end of the polynomial. Alright, so what we want to do is look for any other terms that have an x and then a y squared. Okay, this third term has an x squared. Okay, the exponent 2 differentiates this term from the first one because this is an x to the first power. We cannot add the first and the third term together. They are not like. Okay, this one is an x squared y, and that also doesn't match the first term, x y squared. However, it does match the third term here. I don't want to draw a circle around them. I've already used the circle. I'll draw a box around these two because they are like. This term is like the fourth one. They're already side by side. And now we compare these last two that we haven't considered, 3y squared and xy squared. This one is not like the first one because there is no x. Okay, and so these two don't combine with any others. We just simply write them on the next line and we don't change anything about them. However, the x terms can be combined to give us a minus 4x, and then the x squared y terms can be combined. We have a negative 6 minus 4, which gives us a negative 10. And then we simply write out the last one that had no like terms, 3y squared. And we didn't get to combine all of them, but this is as far as we can go. There are no other like terms among this polynomial. This would be our final answer.